So really what we just kind of looked at was we had learned how to find slopes of things and then how to draw graphs. So like I said, I'll give you a chance you'll get a chance if you haven't yet to check with that recording. I'm happy to answer any questions as well. But we'd really just gone through and learned how to draw graphs. We, making sure that we have proper scale and X and Y axes, stuff like that, making sure we're able to generate data like what we have here. And we put that in there. And then we also looked at being able to find the slope of a graph using our formula here, which is the y2 minus y1 or divided by x2 minus x1. There's an explanation as to what those are in here. So if you're looking at that, you're like, what does that mean? Don't worry, it does get explained. So what we're going to do now is we're going to keep going and we're going to work on start on page 17 here. And we're specifically going to be looking at partial linear relations. I'll zoom in here. What did I say, page 17? So most of the graphs that we've looked at so far have had it's called a direct linear relation. Again, that direct one, a direct linear relation is when we're going through this thing here, 0, 0, that's the origin. To give you an example, a direct linear relation is going to be going through this point here. You're going to have a line goes through your 0, 0 line here, and it's just going to be a nice straight line. Any of these are all direct linear relations. A nice example there that kind of encapsulates this is the one we did up here, which is graphing your earnings from babysitting, right? If you work 0 hours, you're not going to get any money. And then it just goes up at a nice steady pace for every hour that you work at. But not all things are like that. Sometimes we have to graph things a little bit differently. So just to give you an idea here, I'm on page 17. Just to give you an idea here, what if we have someone who is an electrician and like if you've ever charged anyone for like if you ever had to get like a plumber or any type of mechanical work done in your house, a lot of these people have charges just for doing it. It doesn't matter whether they're there for a second or whether they're there for 10 hours. They have a basic charge as just a call out fee. So in this case, in example 3 here, we can see that we have an electrician here. And when he makes house calls, he charges $45 plus an additional $35 for each hour of work. So if he comes in and he does no work, he just looks at your sink and he's like, yep, it's broken. Nothing I can do. Walks out. You have to pay $45, right? You're paying $45 for his time to get to your house. So if we were to graph that, it's going to look, probably something like this. We're now no longer going through this big origin point. It's not happening anymore. So let's start going through this. So when it does not pass through 0, 0, we call that the origin. That's when it's a partial linear relation. So direct is when it goes through that. Partial is when it does not go through that. So let's try and graph this data here. So first off, we want to create ourselves a nice little table of values. Now this has been generated for us before, but now we need to actually do this ourselves. And this is going to be showing his earnings after each hour of work up to 5 hours. So we want to show his how much he's going to make for every single hour. So we do what's called a T chart. Literally, I'm just going to go through, I'm going to draw a giant T. I'm just going to make that a little bit neater. So in this T chart, what we really want is we want to know there's two things. There's two different sets here, right? There's the amount of time he works, the amount of hours, and then there's the amount of dollars he's going to earn, right? So I've made a little T chart here, and all I do is I'm just going to put hours on one side, dollars on the other. I put my X and my Y on here. As we went through yesterday, there's an independent and a dependent. I can just come up with however many hours he works, right? If it's an independent, it's going to be my X value. But how much money you make is dependent on how many hours you work and what your salary is. It's a dependent value from what we saw up above. So that means this is going to be on our Y axis. So this wanted me to create a table of values showing his earnings after each hour of work up to 5 hours. So what does that mean? I wants to know how much he's going to earn at 0 hours, 1 hour, 2 hours, 3 hours, 4 hours, and then 5 hours, right? So there's 6 actual data points here. How much does he make if he works no hours? 0. He actually makes 45 because remember, he charges to come out there. So even if he shows up and does no work, you're paying 45 bucks. But then after he keeps working, now you already have him here. You've paid out that call out fee. Now how much does he make every single hour? 35. Yes. So it's going to go up by 35 every single time now. So I'm not going to put $90 here. I'm going to put $35. So it's going to go up $35. So $45 plus $35 is going to give you 80. And then it just keeps going up and up and up like that. So it goes from 80, another $35 would be 105. You got another $35, you're gonna get 140. And then it's gonna be 210, I believe. No, sorry, I think I've messed up here. I've done some math. Yeah, not 115, it'd be 115, not 105. Everyone makes mistakes. And then 150, 185, and 220. Sorry, I just made that mistake here. I put 105 instead of 115. Again, easy to make mistakes. That's why we have calculators that we're allowed to use that make our lives a little bit easier. So I've done the first part. I've graphed a table of values. I like calling them T-charts, but it means the same thing. And not only that, I now know which one of these is going to be X and going to be Y. So the next question it's asking me is I need to draw a graph of this data. I'm just going to scroll up for a second. I'll scroll back down. But when we draw a graph, we have a couple of rules here. And again, this is in that recording in case you don't have it. But you're going to label the X and Y axis. We're going to generate our points. We're going to label the dependent and independent values. We've done that already. We've generated our points. We're going to find an easy scaling, and then we're going to plot the points. So all we have to do is label our X and Y axis. We have to find our scaling, and then we have to plot our stuff. So this is, I'm just going to erase. Oops. Here we go. So on this chart here, this chart is always going to be a 15 by 15. I've used the same one throughout the entire class. Without exception, it will always be 15 by 15. And then I need to label my X and Y lines. The lines that go on the bottom here is our X, and then going from up to down is going to be our Y. So I've labeled it. I've generated a table of values. I've generated my points. I know what my independent and dependent variables are. That's my X and my Y here. So now all I have to do is I have to label this stuff, right? So if I have a total of 15 lines here, I want to try and make sure I can fit all 6 of these data points. There's not 5. There's technically 6 here within there. So I'm going to start out with 0. That one's already done. Now I have a total of 15 lines left, and I have 15 spaces. I want to fit a nice, easy number. So I take the amount of lines I have, figure out the amount of data points I have to put in. I can go every 3 lines can be 1 hour. You could do 2 as well, but you want to try and use up most of your graph. So 1, 2, 3, that's going to be 1. So all I'm doing is I'm just going in here and I am 2, 3, graphing it. Again, everyone's graphs are always going to look a little bit different because maybe you chose 2 as a scaling, and that's totally fine. I wouldn't say you want to go up 1, 2, 3, 4, 5, because then you're only using up like this much of the graph, right? That's not a lot. You want to try and use up at least half of each part of your graph, if not more. And I'm going to label it because this is the amount of hours worked, right? 0 hours, 1 hour, 2 hour, 3 hour, 4 hour, etc. And now on my y-axis, I have to go up a total of $220, right? So you want to think of a nice easy scaling. What I like doing is I just take the amount of data, which is 220. I divide it by the amount of lines I have. Each line needs to go at least 14.6667, but that's going to be really awkward, right? You're not going to go here and write, this is 14.67. This is, 19 point whatever that is. You want to pick an easy number, right? I'm going to pick a nice easy number that's bigger than this. I'm going to go with 20. Maybe you decide I'm going to go with 15, but I'm just going to go with 20. So each line that goes up is going to be an extra $20. It would still work with 15. Yes. Yes. Like I said, everyone's graph is going to be a little bit different. A lot of people might go 15 there, and that's fine. I always just say pick a really easy number for it, right? Let's go up by 2s, 5s, 10s. Our brains work pretty easy with those numbers versus going up by like 0.5s and stuff like that. So I'm just going up every single line is an extra $20. Then this is 220. And sure, why not? We'll just put 240 in there as well. And also, I'm just going to label it. This is in dollars. So now I've done steps 1 through 4 from the stuff that we looked at yesterday. The only thing I have left to do is I just have to plot my points. So I'll let everyone get caught up in just a second here. So I'm just going to plot my points now. I know at $0, I go to 0 on my x-axis, I make $45. I don't have $45 on the line, right? So all I'm going to do here is I'm just going to estimate, like, hey, if this is 60, this is 40, halfway through is about 50, right? So somewhere around right here is probably 45. It's not going to be perfect, and that's fine. We're drawing these by hands. There's going to be some human error in it. You're just doing your best guess. So at $0, he makes $45. At 1 hour, he makes $80. So I find where 1 is on here, and I just follow it up along until I eventually find 80, and I plot my point. At 2, I go up to 115. That's not directly on here, so I'm just going to do my best guess at where it is. At 3 hours, it's 150. At 4, it's 185. And then at 5 hours, it's 220. So all I've done is I plotted my points. And if you've done it right, you're going to look like, you can just look at this. You can already tell that a nice straight line is going to fit through that. If there's something that, if it's not going to fit through that really nicely, then you're going to know that, oh, I put a point somewhere wrong, and that's fine. Just quickly erase it, fix it. Everyone makes mistakes with this stuff. So I'm just going to connect my points now. So a couple questions here to kind of like ask ourselves. So first off, is this a straight line? Yeah. Yes. If it's a straight line, it's a linear relation. That's what the whole unit is about, is straight lines. Now, my question for you is, does it go through the origin, 0, 0? No, which would mean that it is a partial linear relation. If it went through this point here, it would be a direct. So we're looking at partials today. We looked at direct ones yesterday. So I've graphed my chart here. Let me do this. Here we go. So, and we just established, is this a linear relation? Yes. How come it's a linear relation? It's a straight line. Yeah, you can write that down if you want. I'm not going to. But that's why. Is it a linear relation? Yes, it is, because it's a straight line. And if it is a linear, is it partial or direct? It's partial because it does not go through 0, 0. So I've answered question B. I'm not even going to write it. Actually, I probably should.
It is partial because it doesn't.
Correct. Yeah, because it does not go through 0, 0. It's a partial. It is, yes, it is a straight line, and it is partial. So, so the next thing here is it wants us to find the slope of the graph, and that's what we had looked at yesterday. Now, and if you remember, I'll actually just load it up. Actually, no, I'll just scroll up. I'll come back down. So when we looked at slope, we had a whole bunch of different formulas here, right? It's vertical distance divided by horizontal distance. It's rise divided by run. It's y2 minus y1 divided by x2 minus x1. The only one you're given here is this highlighted one on the right. That is what you'll be given on your departmental final exam. The rest of the stuff are ones that you kind of just need to like have an understanding that, oh, it's rise over run. But this one you do not need to memorize. You do not need to memorize this highlighted one, but that's what we're going to end up using here. I'm going to scroll back down. Oops. So we want to find the slope of this graph. And when we have a graph, it's very important that we use 2 points, because I can't just look at this and be like, let's say I'm going to pick this highlighted point here. That's not going to work. I can't just be like, oh, the slope is 80 over 1. It goes up $80 for every hour he works. That doesn't work out this way because it's not a direct linear relation. You can't just look at it and be like, that's the slope. You actually have to do some math now associated with it. So question C is, we want to find the slope of this graph. The second we want to find the slope of a graph, we need to use 2 points. And when we're finding slope of a graph with 2 points, we need to use our formula. So step 1 is always, we're going to put in our formula, which is M, which is the fancy word for slope, is equal to y2 minus y1. I'll talk about that in just a second. And I'll put the 2 and 1 in there. Divided by x2 minus x1. Here we go. And you're noticing I'm putting really small numbers here. It's not x squared and y squared. It's just saying it's reference on the fact that it's the second y. So this is always going to be our formula when you're trying to find a slope with points. You have to use 2 of them. So what tends to confuse a lot of people is what the heck does each of these things mean? So let's go through that. I'm just going to erase my highlight here. Oh no. Yes, there we go. I think it was like right here. Okay. So the first I need to do is I need to pick how many points? I want to pick 2 points. Any 2 points. It does not matter which 2 points you pick. I like going for nice easy numbers. I'm going to go for this one here. I'm going to use the end point, and I'm going to use my first point. So we always, when we're reading this like the coordinate of this point here, of this last point here is, it's always X and Y, right? You always read the X one first. So the coordinate of this point is going to be 5. I'm actually going to type that in. The coordinate of that point is 5 and 220, right? That's what that point is. Now, what's the coordinates of my other highlighted point here? The one at the bottom?
0 minus 0 and 40.
0 and 40, right? Yes, because it's 0 on my x-axis and it's 40 on my, sorry, it's 45 on my y-axis. Yeah, we want to make sure we use our chart, our T-chart data, because again, we're all humans. We're not only going to place it right. We want to use our actual generated data, not just what it looks like on our graph. So I now have 2 points. I've done that. But the question I get from a lot of people is, what is this y2? What's this y1, x2 and minus and x1? Like, what are those things? So when I'm looking at this here, when we read a book, we read it from left to right. When I read a graph, I read it from left to right. I'm going to start at the left side of the graph down here, and I'm going to follow it along to the right. Which of these 2 points am I going to encounter first? 0 to 45, right? So this is going to be my first point here. This is my first point, and this is my second point. So that's where those are going to come from, which means, hey, if we always put X first, this 0 here, that's an X, right? This is my X1 because it's the first X I see. This is my Y1 because it's the first Y I see. And now over on this point, the 5 and 220, this is my X2 because it's the second X I see. This is my Y2 because it's the second Y I see. That's where those come from. So all formulas, half of the course is honestly going to be, what's your formula? We've done that. Check. The next part is, yeah.
One quick question. How you have 1 point for, I believe that's X, right? Like X0 and X5. You would do the same thing in the formula, and then it would be whatever numbers are left. You do the top number over the bottom number. And that's your slope.
Well, we're going through that right now. Yeah. So I have my 2 points. The next part I have to do is I have my formula. The next part is always going to be substitute. So just like those steps we have from up above from yesterday, I'm going to substitute. I don't know what my slope is, so I'm going to bring an M as it is. But I know what my Y2 is. My Y2 is 220. I'm going to actually type this in, make this neater. So my Y2 is 220. I'm going to take that away from my Y1, which is 45. And then the whole thing's divided by X2, which is 5. And that's going to subtract 0. So step 2 is substitute. I've done that. Yes, I have. Check. I'm just going to scroll down a second. So now my third step is I am going to simplify it, which means I'm just going to do some of the math that's in there, right? So I'm going to take 220. I'm going to subtract 45 from it. That's going to give me 175. Thank you. And 5 minus 0 is obviously going to give me 5. Now, I have a slope now. It rises. He earns 175 dollars here for every, it's going up 175 for every 5 that it runs. It rises 175 for every 5 that it runs. Now, I can simplify that though. Like, does that make sense? Wouldn't I want to know how much it goes up for every 1 I have a run of? So you can always simplify this to the best of your ability. First off, if you're not great with numbers, you can always use your calculator. If you're pretty decent with numbers, you might realize, oh, I can just divide both sides by 5, and I'm eventually going to get 35. Now, your slope is not 35, though. Your slope is 35. There's a little invisible 1 here. So it rises 35 for every 1 it runs. And I can kind of check this, right? So I'm going to circle this because this is the final answer. This is my slope. I always circle my final answer. But I can always check this. I can go to my graph and I can see that, okay, did I go, if I run 1, did I go up 35? It looks like I did. If I run 1, did I go up $35? Yes, I did. And so on and so forth.
Quick question.
Mm-hmm.
With, I've done some other things that questions we've gone through that. It's they'll be given a decimal point instead of the fraction. Should we then turn that decimal into a fraction?
Ideally, yeah. If you're specifically trying to graph it, yeah, you will want to probably turn that into a fraction. And worst comes to worst, there's always a little invisible 1 under there. Yeah. So that's question C. That's the slope of the graph. Now, what does this represent though? Like, what does this actually mean? This 35 over 1.
It's like a constant rate.
Well, well, what does this line represent? Like, what do we actually graph?
hour. It's 35 an hour.
Yeah, we graphed this dude's salary, right? How much does this dude make every hour? So what does this slope represent? What's the slope of the graph? What does it represent? It represents how much he gets paid every hour. How much he's gonna earn that's a better way. And let me do that. How much he earns every hour is probably a more formal way of doing it. Earns.
Another question, also with that, salary and say like, yeah, someone's on salary and something like hourly. They seem the same, how are they different?
I can probably talk about that afterwards.
Yeah, okay. Cause realistically, like how I'm looking at it, and how we talk about it and all that, salary and hourly, do you realistically see them the same?
Kind of. I'll get into that more at the break. Then the next part here is now this is a new term for us, the y-intercept. I know it's a really busy chart right now, so I apologize, but what is the y-intercept? Well, the y-intercept. Did I not? Oh, I did not. Did I not give you guys definition for that?
No,
So,
No, I did not. Okay, new definition time. Okay, still improvements to be made with this. I'm gonna get you guys to scroll up to the top of page 17 here. So the y-intercept, new definition. This is the point. The point where the line passes through the y-axis. I will visualize what that means in a second. It's very important though, what this is. We will be looking at this a lot, this unit. The y-intercept is actually quite an important thing.
I guess it was on there. After partial.
Oh, yeah, but I want it over here. That's what I meant to put it. I meant to put it over here. So I'm gonna get rid of this image next year. So y-intercept is where the point passes through the y-axis. In this case, that's this big highlighted thing here, right? This 40, that's when it passes through this line. When I say the axis, I mean, I'll draw it in a nice thick blue line to kind of represent it. I mean, this thing right here, right? All this blue line here is the y-axis. And I can see it passes through at this point at 0 and 45. Specifically, the y-intercept is going to be 45. That's when it intercepts it. So the answer to question D, I'm going to actually go put this down here. I keep forgetting I gave you guys extra space, is the y-intercept. The y-intercept is, it's just 45. I already know what the X value is. By saying, hey, it's the y-intercept, you are telling me the X is 0. I don't need to write that additional information. Mathematicians were lazy. They didn't have a lot of paper. So they'd say the y-intercept is 45 because that's when it passes through that y-axis. So, and what does this represent? This represents the base fare, base cost of $45, right? When you call this guy out, he's charging you $45. That is how a lot of skilled trade people work. When you're calling them out, it takes them time to get there. It takes them time to bring their tools in, figure out what the problem is. They're charging you whether they're going for a second or not. If you've ever ordered food on like Uber Eats or I don't know all the apps. I mean, we're in a small town, so I don't actually know them all. You're charging a base fee just for the service itself.
That depends, actually.
I could, there's different apps.
If complain and then yeah.
Yeah, fair enough.
People just do that just to get rid of that.
So what we're gonna do here, hope everyone has that down. So what we're gonna do here is, I'm gonna get you guys to try out question 7 here on your own. I'm gonna get you to try and draw this graph here. I'll slowly be adding to it as we go through, but the goal of this is try, use your notes, guess. That's how you're gonna learn, right? And it can be a little frustrating sometimes to be able to do that, but you're going to learn if you're struggling with this stuff. Like that's how it is. And we'll slowly be going over it. So I'm going to give you guys like maybe like a couple of minutes here to try out question 7 as far down as you can go. There's a B, there's a C, there's a D, all that. I'll slowly go through it for a bit, but I'm not going to do anything for the next minute or so. So I'll give you guys some time for that. I'm going to pause the recording. And so if you're not too sure yet, your distance driven in this case is going to be your X, that's independent. And your cost is going to be your Y values. And as you can see from my chart, what I've done is I've just gone up by 1 kilometer at a time on the x-axis here. But you're going to notice I didn't put this 1, I didn't write 1, I didn't write 3. I just wrote every 2 numbers just to make it less congested. You can do that, but I know that, well, where's 1? Well, it's this line right here. Where's 3? It's this line right here, and so on and so forth. Same thing as what I did with the cost. I just went up by $2 every single line, but I didn't write 2, 4, 6, 8. I just wrote 4, 8, 12 every 2 lines distance. You can do that. It just cleans it up a little bit. It's whatever you prefer. So next, all I'm going to do is I'm just going to start plotting my points. I find out 0 kilometers is driven. And I'm going to go to the cost of it. I don't know exactly where 450 is, right? It's not very clear to me. So I'm just going to do my best guess as to where I think it is. And same thing with all these other values. At 4.2, I don't know where 4.2 is very cleanly on here. So I'm just going to do my best to try and find it. And I know that at 4.2, I get $10.80 as what's in my chart. So that'd be $10. And let's say, sure. This seems right. At 6.8, it's 1470. So again, you're just doing your best here. It's not going to be perfect because we have these weird numbers, right? Those decimals. Decimals tend to be like something that throws us off. We know how to do it, but oh, there's a decimal and it scares us. And then at 12 kilometers, it cost me $23.50. So I just follow along my 12 line until I get to 23.50. So then all I have to do is I just have to connect my points now. So it should be a nice straight line. Your guys is going to be straighter than mine because I'm doing this freehand on a mouse. But I should get something that looks like this. So I'll just leave it there for a second. So I'm going to try out this next question here. Now, this is one where it's actually telling us it wants you to choose 3 points here. And you want to choose 3 points specifically from your table of values, not just from your line itself. I know it says line here, but this is going to come from your T-chart, your table of values, because those are going to be exact. This is done freehand. We are not computers. This will not be an exact graph, right? Like, look at mine. It's not a straight line, right? Because I have a wobbly hand. So we want to calculate the slope between the first 2 points and then between the second and third points. So you can pick any 3 points you want on there. You may have started this already. I'm just going to pick the first 2 points I see, which are these two. So that is, make this smaller. I'm just going to quickly write them in. You don't have to do this if you don't want, but 0 and 4.5. Those are that's the first point. My second point was 4.2 and $10.80. And so my question for you is, which of these 4 points is my X2?
X2?
Yeah. Yeah, it's going to be this one, right? Because this is the X value of the second point I'm going to see as I read this from left to right. You do not need to graph this every single time. Eventually, this will become second nature to you. I'm just doing it because it's an example. I'm just labeling my points here. It's not a necessary step to label those points if you just know what they are. So I'm going to go in here. The second I'm trying to find a slope of a graph. I know I need to use my formula. M slope is equal to y2 minus y1 divided by x2 minus x1. Not a very good line. So I've done that. Now all I have to do is step 1, what's my formula? I have it. Step 2, I need to substitute stuff. I'm just going to zoom in a little bit here. I already established what my y2, y1, and x2 and x1 are. I'll come back down here. I already established them up here. So I'm just going to take these points. I'm going to transfer them down here. So I said my x2 was, my y2 was 10.8. You can put 10.80 as you want as well. It's not going to change it. Minus $4.50. And then that's all divided by 4.2 subtract 0, 0. So if I do that, 10.8 minus 4.5, calculators are allowed in the class. It's going to give me 6.3. I'm just going to write that in for now as a decimal, 6.3. Divided by 4.2. Let's simplify that. That's not a very clean number, right? We want to try and get at least one of those decimal points away. So I'm just going to quickly put 6.3 and then 4.2 in my calculator. Your calculator can do the heavy work for you most of the time. 3 over 2. A little bit of an easier number there. 3 over 2. That's the simplified. These mean the same thing. It's the simplified version of it, though. So that's my first 2 points. It wants me to find 2 slopes. So I've done between the first 2 points. Now I need to do between 2 and 3. I need to do the second point and then a third point. So now I need to go back up to my graph and I need to pick another point. I'm just going to keep going and I'm going to choose this one here, which I know the coordinates of are 6.8 and 14.7. Y3, X3 and Y3.
I think I have a quick question. You're saying those are coordinates, right?
Yes.
Like how you would read it on the graph. So is that how you would also read it, say, on a map?
Yeah, yeah.
Yeah.
Yeah. So what I have here, X3 and Y3. So something that's really important to note here is now it's giving me 2 more points. It's saying the second and the third. That's where I got that X and Y3 from. But that's going to cause a complication in just a second. So I'm going to solve it the same way, right? I put in the same formula. Y2 minus Y1 divided by X2 minus X1. Make that a little bit smaller. It's done the same way. Now the only question is, what's my new Y2? What is the second what's the second point I'm going to see on here? It's going to be this one here. You're right. It's going to be these 2 points right here that I'm drawing the arrows to, because I no longer care about that point. I've established I'm only now using the second and the third point, which means the 6.8, 14.7, that's the second one I'm going to see as I read this graph from left to right. So that's my new Y2, is that 14.7. And that's going to subtract, and that's subtracted by my new Y1, which is 10.8. So it changes if you have to use more than 2, for example. And then that's all divided by X2, which was 6.8 minus 4.2. So again, calculator can do the heavy lifting for you. 14. I need to get you a calculator. Whoops. It's going to be 3.9 on the top. Divided by 2.6. Again, that's not a nice clean slope. You want to at least get rid of one of those decimal points. So your calculator again will do that heavy work for you. You punch it in on there, 3.9 divided by 2.6. And I use my change button. I can see it's the exact same slope. So this is a way to verify that you did it correct. If you pick a second and a third point and you get the same slope, then that tells you that 1, it's a straight line, and 2, you did the first one correct. If you get 2 different numbers here, you either made a small error somewhere, or the line itself is not straight. Those are the only 2 things we can kind of get from there. Yeah.
You don't have to put like 3.9 or 2.6 in the calculator, right? You could put the entire equation in and.
On your calculator, yes, you could. Yeah, actually, yeah, you could do that. Yeah. Yeah, you could do that actually. Yeah.
You decide like the field to like what you like 1.5.
Oh, you picked a different number? It should give you the exact same. Yeah.
Well, no, just like instead of like the field to put.
Oh, you put 1.5. I'm gonna say try and stick to that's a good question. Try and stick it to a fraction when you can, because this just easier shows that it's rise in 3 for every 2 that it runs. Sometimes when you're putting the slope into an equation, though, you actually do want a decimal. So it's we have to be a little flexible with it sometimes. I would recommend try and keep it in a fraction if you can, because you can always work it in as a fraction if you want, but there is occasion where we do want it as a decimal. Yeah. So this third question here is, what does the slope represent? The slope of this line? Oh, sorry. Yeah. So it's the amount, it's how much is charged per distance. Yeah. The slope represents how much money is being charged per distance traveled. Distance traveled. Specifically, for every you're charged $3 for every 2 kilometers you're driven, right? Because the 3 is my rise, and I know that my y-axis was my dollar account. So if you wanted to get really specific here, you could say that you're charged $3 for every 2 kilometers, or $1.5 for every single kilometer. And so again, what does this y-intercept then mean of this graph? Partially, you're on the right track. I'll scroll back down in a second, but this y-intercept here of this graphic, what is that actually? I'll mark that in blue. So this point here. Yeah. When you first call a taxi, when you get in, it doesn't start at $0. Yeah. So the start in, so the y-intercept of this graph represents, the taxi has a start in call out wage, right? When you call a taxi and you get in, doesn't matter if you go a block, you're paying a couple dollars, right? Like right from the get go, right?
There's no reason to think because it's not bad to wait another way. That cost you a bid or like give the heads worth of money. You don't have to charge them 10 cents a ton for the road.
Yeah. So I'll just leave that up there for just 1 second here. So we're going to do one more together, and then we'll give you guys some time to practice this, because I know we've been talking for a lot. It's helpful to not just it's helpful to be able to apply this stuff. So we're going to do one more here, and it's not going to be question 8. So question 8 is going to be one that you're going to be able to come back to and try out later if you want. I'm actually going to scroll on down here to the next page. Is this what I want? What page is this? This is page 20. Yes, okay, to page 20. So with this here, we're sometimes going to be working now with negative slope. This is where it's a little bit newer to us. So most of the graphs we've looked at so far have followed this format, right? We're sticking to one quadrant of here, and the graph's going up as we go from left to right. Sometimes it starts in the origin, sometimes it doesn't, but that's been the theme. Now we're going to work with graphs that go down as you read from left to right. So generally speaking, if you have a graph that is going up from left to right, it's a positive slope. If you have a graph that's going down from left to right, it has a negative slope. So if I give you a graph that's like this, doesn't matter whether it's direct or partial, that is a positive slope. If I give you a graph that goes down as you go from left to right, that is a negative slope. So you read it like a book from left to right. So let's see this in action here. So we have an example here. So if we have someone who has a car, they have a car full of gas, it has 40 liters of gas in it in the start, right? She just went to Sev or the co-op, filled it up, and now she's going to go travel. So she knows if she travels at a fairly constant speed, the car uses 1 liter of fuel for every 9 kilometers of driving. So we're gonna make a table of values for this. We're gonna make a T chart to represent all 4 of these different values. Now, sometimes it might just tell you, make a table of values, period, end. In this case, they're giving us some example values. If you're not given any example values, you can make up your own. You can just be like, well, what happens if he drives 50? What happens if he drives 100? So sometimes you're given some, sometimes you're not. But in this case, we are given some, we're going to use those. So let's go make a table of values or a T chart with this.
That's if you're giving the table of values or.
You're making it, if you're given a table, sorry, what's the question?
It's like the numbers, like if we're given this 40 liters and this.
Yeah, so you can use the numbers they give you in this case, but
If they don't give us either, but they want us to do like the same question, but with numbers, then we ourselves.
yeah, then you yourselves are just gonna pick, screw it, 100 kilometers. You're just picking random numbers out of the air. So what we're gonna do here is we're gonna make a table of values. Now, what's the data we're checking here? We're checking how much fuel is used and how far this person's gone, right? So that's what we're gonna check. So I'm gonna put the distance and the amount of fuel remaining. Because remember, we're not checking actually how much fuel was used. We're checking the amount of fuel that's still in her car. So it's not the fuel used, it's the fuel remaining. And I already know my values. I know it's going to be 0, it's going to be 45, 90, and 135. So first off, when she hasn't driven yet, she just filled up her car. How much gas is in her tank? 40 liters. There's still 40 liters remaining in her tank. But now the question is, well, how do I figure out how much fuel is left over for these 3 values? This is where we need to use one of those skills we learned with last class, we learned with yesterday, to be able to do. So how I'm going to figure out this 45, this 90, and this 135 is pretty simple. How much fuel does this person get? Like what's their like fuel per hour? Or yeah, 1 liter of fuel for 9 kilometers, right? So I know that I have 1 liter of fuel for 9 kilometers. So what happens if I take that and I just go 45 kilometers with it? I'm just gonna type that, make it liter. So why don't I just take 45 kilometers and why don't I multiply that with 1 liter and 9 kilometers? And that's going to spit out a number. That's going to spit out how much I've actually used here. So 45 times 1/9, 5. So I can see here that 5 what? 5 kilometers or 5 liters? Liters. Because these are canceling out if we're thinking about really the math part of it. Or if we're using our logic, so well, I just want to know how much fuel I've used. So I've used 5, sorry, I've used 5 liters. But how much do I have remaining in my tank then? 35. That's a very common mistake to make, right? I even just did it. I just put 5 in there before I caught myself, right? Where you're going to slip up with these things is those really small mistakes. So then I do the same thing for 90 kilometers. And you don't need to write this down every time. Like if you know what you're doing, you can just quickly punch that in your calculator and that is totally fine. Just because it's an example, I'm showing all the steps here, but I just do the same thing. 90 kilometers times 1/9 is going to give you, in this case, it's going to be 10 liters if you punch that in your calculator. Which means how much fuel do I have remaining? 30, not 25, but 30. Because it's 40 minus this 10 liters. And then again, you could calculate it out. I'm not going to write it down in this case. You would end up with 25 liters left over. and our fuel remaining here. You can probably already see the pattern, right? You can see that, oh, every 45 kilometers this person drives, they lose 5 liters of fuel, right? You've seen the pattern now. You could probably already identify what the slope might be. But so I've done my table of values. And that's check for question A. Now, question B is we want to draw a graph of the data. Well, we have the data. All we have to now do is quickly graph it, right? So I'll give you guys just a quick minute here to be able to graph that. So once I've plotted my points here, I've set up my scaling. I'm just going to quickly, like looking at this, first off, before you even draw the line, does that look like it's going to be a straight line? Yeah, it does, right? So you've probably done something right there. Oh gosh, that's not a good line, but I'm on a computer. I'm allowed to do that. You guys should use a ruler. So I am going to make that neater. I'll make that neater. But so as we can see, as this graph goes from left to right, it is going down. It has a negative slope. So you should get a graph that kind of looks like this. Now our next question here was, so B, I've drawn my graph. The next question is calculate the slope of the line. So question C, I still do it the same way. I'm still going to solve it the same way. I know I'm still going to use that M equals, I'm just going to write Y2 and Y1 now. I'm not going to freehand that little one just to make it a little bit neater for you guys, make it a little bit faster. But it is supposed to be a very small 2 and a very small 1 there. But I'm kind of limited by the technology I have. Like it's supposed to be that, right? A very tiny one. But that's fine. I'm just doing it on a computer. So I still solve it the same way, which is I'm going to find my formula, and now I need to substitute values. What values do I need to substitute? Any 2 points. It does not matter which 2 points you use. I like using the first and the last, personally, but you don't have to. You could use the first 2, you could use the last 2, you could just pick any 2 points. It will not matter. So of my 2 points here, what's my Y2? My Y2 is, remember, we read it from left to right. It's going to be 25. And then what's my Y1? 40. So it's not just the biggest numbers. We already know for a fact that this is going to be a negative slope. It has to be, because it goes down as we go from left to right. This is the second point I see as I read this graph from left to right. This is the first one, and it's always done with X and Y. That's where I'm getting those numbers from.
And that's always the first point is on the most left side.
Correct. Yeah. Yeah. Always left. Yeah. You read it from left to right. Yeah. So, and then my X2 and Y2, my X2 in this case was 135. I subtract my Y2, which was 0. 25 minus 40, negative 15. Negatives and decimals always seem to throw people off, but you're still solving it the exact same way. Your calculator can do a lot of this heavy lifting for you. So negative 15, 135 minus 0 gives me 135. But that's not done, right? So step 1 was, do I have my formula? Where's my mouse? Yes. Step 2, I'll actually write the 1, 2, and 3 here. So just like what we figured out yesterday, step 1, what's my formula? Step 2, substitute your values. Step 3, I now need to simplify this. So your calculator can do that for you here.
How do you get it?
I was just about to actually talk about that. So you don't, to use a negative, your calculator is going to have a negative. And someone had asked me if I can share this program here in case you don't have a calculator at home. I can do that. I will upload that to the LMS introduction section by the end of today. So you will have that available. You just download it and it turns into this program. But anyways, what I do is I use my fraction button and I use this negative button. It should be near the bottom of your calculator. Then I put 15 over 135. And if I do that, you're going to notice This is kind of actually quite important. This little negative, it goes from the 15, now it's beside the fraction. Because remember, the slope itself is negative. It's just transferring that negative there from that 15 to the actual full equation. So if I simplify this, I can see the whole thing is actually -1/9. It's not -1/9. It's the slope is negative and the slope is 1/9. So you're noticing that I've actually moved this little negative point here. So why is the slope negative in here in this case? Because it's declining, yeah. Specifically, it's because we're using more, there's less fuel in the tank as we go, right? The more distance she travels, the less fuel she has left in her tank. She's going to eventually get to the point where her tank's empty. Now, I'm pretty confident you guys would be okay with, we just did C. I'm pretty confident you guys would be okay with the latter part of C and with D. Question E is a little weird. So first off, if you did a really big graph, you could just kind of look at, you could just eyeball. Like if this line went all the way down, you could eventually figure it out. Now we like using our graph space here, so that's not going to work quite well. So instead, you could use algebra for this. So specifically with question E, question E is asking, how far can Josie travel before she runs out of fuel? Well, so here's what I know. I know this person's fuel mileage, right? It's 9 kilometers for every 1 liter. I also know how much fuel is in her car. Now remember, these two fractions need to keep the exact same ratio because they're following that same slope. So there's two ways that we can solve this, but what I'm trying to find here is I'm trying to figure out however many kilometers there is. Now we don't use question marks in math. Normally we kind of substitute that for the biggest one you've probably seen is X. I want to figure out what X is. X just means I want to figure out how many kilometers this person can drive until they've used all of their fuel. So you could either use algebra, which would mean that, oh, I need to get rid of this 40 liters, right? So you do the opposite. Right now it's being divided by 40 liters. You'd multiply it.
What's the technique where you do your hands? Because you do that.
I'm not like with your hands.
Yeah, like 9 times 40, like 9 times 40.
Oh, I'm not too sure there.
Because you should do 9 times 40. I mean 9 times 4.
Oh yeah, I'm
9 times 10.
yeah, I'm not too sure with that one, but so specifically for this one though, so you could either use algebra or you could figure out that first off, there's two ways. I'll do it both ways. First one times some magical number is going to give me 40. We can just eyeball this one. 1 times 40 gives me 40, which would mean the same would be true up here. 9 times 40 would give me my answer. That's one way. I'm trying to encourage some algebra use here. So specifically, I'm going to do the opposite of what I see happening here. Right now, I can see that my X is being divided by 40 liters. So I need to do the opposite of dividing by it. I need to times both sides by 40 liters. Again, algebra is just a skill we're going to slowly acquire in this course. But I need to get X by itself. I want it to tell me that, hey, X is equal to your answer. I want it to tell me what that is. So that's why I'm getting X by itself. These two things are going to cancel out. And what I'm left with is, oops. What I'm going to be left with is I'm just going to follow exactly how it says. It's going to be 9 kilometers over 1 liter. I'm going to write that in. I'm making that messy. It's going to be 9 kilometers divided by 1 liter. And all of that is being timesed by 40 liters. So you can punch that in your calculator exactly how you see it. And what you're going to eventually get here is I can see that it's going to be 360 kilometers. There's two ways of solving it. I recommend the algebra way because if you can get algebra down, you will breeze through the rest of the course. But the final answer here is how far can this person travel on 40 liters of fuel? It's 360 kilometers. Okay. So what I'm going to give you guys is, so we have about 10 minutes till our break here. I'll come back down to this if you're still writing stuff down. But what's going to happen is after the break, so at about 2:15, we're going to finish this up. We have one more thing to learn here. Actually, yeah, no, when we come back, we're going to finish this up. But for now, what you guys can do is you guys can try out question 8. You can try out question 9. And you can try out question 10 here. When we come back, we're going to finish off this last part of this section. But so you guys got about 10 minutes here. Take your break if you want it, just to try out those next 2 questions here. When we come back, we're going to finish off this section. So what we've looked at so far with graphs is we've looked at a couple different ones. So what we've looked at so far is we've looked at linear relations. We've looked at partial linear relations. We've looked at negative slopes as well. The one thing that can kind of be different now, though, is, well, what happens if we have a slope that kind of goes like that? That's where we're going to kind of conclude today's lesson, and which is on page, 25. We're just going to page 25. So up on page 25 here. So we also have non-linear relations. The chapter is called linear relations, but we have to be able to identify what's the difference between a linear relation and a non-linear one. And at its core, a linear relation is a straight line. A non-linear relation is a non-straight line. So not all data is going to form a straight line when you graph it. So let's try this out here. So we have an example here, which is we have a secondhand store. What's it called? What's that one in Saskatoon called? Crap.
Goodwill.
Goodwill, bargain something. What is it called? I'm having a brain fart right now, but yeah, like a liquidation store. Like you go, you donate something to it, they resell it at a much cheaper price. Yeah, stuff like that. Stuff like that. Yeah, okay. People know what I'm talking about. At least I'm not going crazy. That's annoying me now. I'm gonna Google it later. It's gonna be like, of course that's. Anyways, so a secondhand store, right? They take in things and they sell it. And what happens if something in a store doesn't sell? Well, you put it on sale, and you progressively put it more and more on sale until eventually someone's like, that's too cheap. I have to buy it. Everyone's had an instance where it's like, that is too cheap to not buy it. I do not need 10 things of cheese, but it's so cheap. I'm going to buy 10 things of cheese. I literally have 6 blocks of cheese in my house. I got them for $1 each. From No Frills, but that's what happens here. So you can probably see where this is going. Basically, is in this secondhand store, they have a policy that if something does not sell, they're going to drop the price by 30% every 2 weeks. So it's going to get cheaper and cheaper and cheaper and cheaper. And that product they have starts out at $50. So we want to figure out what's going to happen to this coat, the price of it, when it goes to 2, 4, 6, and 8 weeks. And we also know what it's going to start at. So we actually have 5 different values here. So we're going to quickly do ourselves a nice T-chart here. And there's not 4 values here because we know what it starts at, right? We know it's at 0, it's at 2, 4, 6, and 8 weeks. Make this a little bit neater. So we're tracking the cost of this fur coat. Now we know when it first hits the floor, it costs $50. Sorry, I gotta label this. This is the week, and then this is the dollar, the cost. So I need to find the data of this. I need to find the cost of what this is going to be like every 2, 4, 6, and 8. And we're working with percentages here. So how we're actually going to do this is I want to know what is it going to be like? What is it going to be after 2 weeks? How much is this going to cost after 2 weeks? Well, here, perfect. So here's what I know. It starts out at $50, right? That's what it's starting out as. So if I want to know, so if it's losing 30% of its value, it's still maintaining 70% of its value, right? So it's going to be 70% of its value. Now, so basically what I want to know is, what is it going to be like at 70%? Percent as a decimal would be this. 70% as a decimal, is this. All I'm doing is I'm moving that decimal. So I want to know, what is 70% of $50? The second I say of in math, you use the word of, it means multiply. This is 70% of $50. So all I'm going to do is I'm going to punch down my calculators. $50 times 0.7, that's 70%, is going to give you $35.00, right? So I now know that this is going to cost $35. I can put the decimals here if I want. Don't need to if it's 00, but. So, okay. The coat's been on the floor now for 2 weeks. It still doesn't sell. Sorry, now it's been on for 4 weeks. Sorry. It still doesn't sell. So now, how much is the coat currently selling for? Well, the $35. It's still selling for $35, right? Now I got to take another 70% of that. Yeah, $24.50. Now the cents actually matter. And okay, now this coat's been on the floor for 4 weeks. Sorry, for 6 weeks. What's going to happen? They're going to dump it down another 70%. Sorry, another 30%. So where I'm getting the 70 from, even though it says, but you're losing 30% of the value, but it's still retaining 70.
Would you still do it for $35?
Oh, no, I would not. Thank you. Good catch. 24 and 50. Again, everyone makes mistakes, right? It's the easy things we make the mistakes on. It's just setting up our work usually. So now if I do that, I'll use my calculator here. $17.15 seems right. And then it just asks us for what it's going to be like at 8 weeks. So same thing, right? I'm going to take its current value according to the store, which is now $17.15. I'm going to find what 70% of that is left. And I'm going to eventually get $12.01. There's other ways you could solve this. You could figure out what 30% of it is and subtract that. That works too. I like doing it all in one nice clean step. So I'll just leave that there for a second. But anyways, you can probably already see that this is not going to be a straight line, right? It's going, I'm taking away 15, then I'm taking away looks like $11, then I'm taking away, $7, then I'm taking away $5. It's not going to be a nice straight graph, right? It's not going to work out that way. So it's a non-linear graph. We can tell just by looking at the data. So at this point, it's nothing new to us. I've made a table of data. Check. Now it wants me to graph that data. That's not new to us. I'm going to quickly power through a graph here. It's the next part that I care a lot more about. So I'm going to quickly power through the graph here. So time is usually going to be our X value. Money is usually going to be our Y, right? Independent and dependent. The amount that this sweater's worth is dependent on how long it's been on the store. That's why it's our Y value. So number of weeks and total value. I have 15 lines. I have 8 weeks of data to put in. I'm just going to go up like one line is 1 week. So this is 2, 3, 4, 5, 6, 7, 8. You could expand it if you want. It's okay if you don't. And then my total dollar goes up 50. I have $50. I have 15 lines. I have uploaded this calculator, by the way, onto the LMS. I'll show you that at the end of the class. So $50 divided by 15 lines. Let's pick a number bigger than that. Let's go up by 5s, right? That seems like an easy number. So each one of these lines is worth 5. I'm just going to say it's 10, 20, 30, 35, 40, and 50. And sure, why not 60? I'm just going to quickly graph this, right? So at week 0, it's worth 50 big ones. At week 2, it's worth 35 bucks, which is about right here. At week 4, it's 24.50. At week 6, it's 17.15. Again, I'm just doing my best guess here, right? It's not going to be perfect. Then at 8, it's 12 bucks. And right away, we can almost kind of tell just by looking at this, this is not going to be a straight graph. We can tell by the data. We can tell just by looking at the points. Now I'm just going to connect the points one by one. Now, we've seen this before. This is kind of a broken line graph, to be honest with you, from something we looked at last class. But I can see it's actually going to be, it's a non-linear graph. If I was to extend this, you know, it probably looks something like this at the end. So I've graphed it here. So I'll give you a second just to get caught up to that, because the thing I really care about is coming up next. I'll just make sure you're all good to go there. I need to find my file. So what we're now focused on is the third question. So first off, is this graph linear or non-linear? It's non-linear. We can tell that just by looking at that. But we want proof. We want to actually prove that this is not a linear graph. And this is where this tends to get a little confusing because, well, how do I prove that? So I'm going to scroll up just a little bit to one of our earlier questions that we did today, which was this one here. This question where we looked at the taxi company rates. We proved that this was a linear graph because we found the slope and we verified that the slope maintains the same, it maintains the same slope. It goes up at the same rate at all points in this graph. So we actually, what we did was we looked at 3 points, we calculated the slope using them, we calculated 2 slopes using different points in the graph, and if they're the same, it's linear. If it's different, it's non-linear, or we mess something up. So we're going to do it the exact same way here. So how do I support my answer? How do I do this? I'm going to find 2 slopes using 3 points. This is our goal now. So we're going to find 2 different slopes. Because again, we can tell just by looking at it, but like that's not a academic responses. We'll just look at it. We'll know how come. We have to articulate it. We have to provide some evidence. So we're going to use slope to support our answer. So I'm going to go down to the next page where I have some more room. I'm going to solve it the exact same way, right? I'm going to find 2 slopes. If I'm finding slope of something, it's y2 minus y1 divided by x2 minus x1, right? And I'm just going to have 2 different ones here. So just make sure you give yourself some space here because we know we have to do it twice. So how do I actually like start solving this? So someone tell me, what do I do?
Is a fine. I would assume one point would be y50 x0.
Yeah, so you're right. I have to find some points. So yeah.
Like I would assume the original point would be
Yeah.
y0 and then maybe the next.
Yeah, you could do that. Yeah. In this case, you don't just want to pick any 2 random points. I would recommend pick one part and then maybe pick another part, for example. I would recommend doing something like that when you're trying to prove that it has the same or different slope. So I'm going to use these 2 points here. That's 0 and 50 and 2 and 35. So 0, 50 and 2 and 35. So m is equal to, I'm actually going to write my points down here. So that's, so my one was 0 and 50. You don't have to do this, but I'm just doing it as a visual reference. And what was the other one? 2 and 35? Yeah, perfect. Okay. So I've just written these points down here. It uses my reference here. So y2 is 35 because it's the second point I see as I read it from left to right. I know it's a negative slope. One of those numbers has to end up negative. Subtract x2 minus x1. So 2 minus 0. And if I do that, I'm going to eventually end up with negative 15 over 2. Which is, if I put that into a decimal as well, it's negative 7.5 over 1 as well. Right? I've simplified it as far as I can go at this point.
You would do it normally in the calculator, right? Then how do you put the negative onto something in the calculator?
So your calculator has you don't do the minus button. It'll actually have a negative button near the bottom.
Okay.
Yeah.
So that's what you would do then instead. Right?
Yeah, and so for an example here, your calculator knows to, like, again, look at where I put that negative sign. It's actually this is a bad example I did there. I'll fix that, but backspace 2. Again, your calculator knows to spit that negative out beside it, which is what I should have done here, which I'll go fix right now. And so now I'm going to do the exact same thing, just with 2 different points. I already established which 2 points up above. I'm just going to go take a quick peek so I can remember which ones they were. Okay, so that's 4 and 6. Okay, so if you're still writing, that's fine. So again, I'm just writing down my points here just so I know. So 4 and so that's 24.5 and sorry. You will not be like deducted marks or anything if you don't do this part, but I have a short memory, so that's why I'm doing it. I don't want to have to scroll back and forth. 17.15. Okay. And just like before, I just substitute my values in, right? Step 1, what's your formula? Step 2, substitute. That has not changed. My Y2 in this case, as I go from left to right, I can see the 1715 is the second Y I see. Subtract the first Y I see, 24.5. You could do 24.50 as well. It's not going to change your answer. And then your X2 is 6, your X1 is 4. So step 2, I've substituted. Check. Third step is I need to simplify. You can punch all this in your calculator in one go, or you can just calculate it one thing at a time. That's fine. I'm going to show you how to do it all in one go because I haven't done that yet. I use my fraction button. In most cases, it's an A/B. And I'm literally writing it in exactly as I see it. I don't need to mix it up. I can use my arrow keys up here to navigate. 6 minus 4. And it's going to give me negative 3.675. But remember, there's always a little invisible one there. So my question for you is, what does this show me? Highlights.
We proved that it's not a linear slope.
Right, we've proved this is a nonlinear slope because the slopes are different. If it is a line, if it is a straight line, that slope will be the same. Those slopes are not the same. Therefore, we can now use this to prove the line is nonlinear because the slopes are different. Sorry, yeah, the line, the graph is nonlinear. Either is fine. So once you're done with this, what you can really focus on, I'll use blue to kind of show this. So what we can really do now is you can finish the questions up to page 32. So you have some questions below this. That's some time to work on this. Now, as I said before, in this case, you guys don't have a lot of time to work on this. Sometimes you will get more time, but it is really important. Like, we're moving at a fast pace. For those of you who are with me, like with the last class, we're moving quick. Like, there's a lot of information coming in here. It is very important that you practice this stuff. Use these questions. I'm not a really big fan of homework, but at least try a couple of them at the very least. You're trying to cement this learning. It's meant to be difficult because if you come in here like, I didn't put much effort for the next couple of days, it's going to be really hard to get caught up at that point. I try and design the class to be as flexible as possible to catch up, but we are at a really set pace because we have that departmental. We have to learn this stuff. We have to learn it to the level that we really want. We want to go as deep as we can with this because it's only going to help prepare us. So with that, I'll give you some time to work up on this stuff. If you have any questions with this, you're welcome to text me. I can't guarantee I'll answer it, especially if it's like late at night or anything. You're welcome to email me. or we can go over some of the stuff tomorrow morning as well, but we will be moving on to unit 1.2 tomorrow. That will be our ultimate goal here. So you might get a little bit of time to work on this stuff tomorrow, but I would say try and finish this as much as you can today and maybe even a little bit tonight.
Again, just the catch. When to text you. Past 10 o'clock.
Past 10, I will be in bed. I wake up at 5 in the morning.